So I want you to imagine, just for a second, that you're trying to find this critical email from, like, years ago.
Oh, we've all been there. It's the worst.
Right. You know the exact conversation happened, you know exactly who was on the thread, but you just, for the life of you, cannot remember the exact words you used. So you type in a few guesses, and you get nothing.
Nothing at all, just zero results.
Yeah, exactly zero. You try a different phrase, still nothing.
Oh.
Now take that very familiar, everyday sort of frustration, and imagine that instead of just looking for, a forgotten recipe or a casual chat, a literal billion-dollar lawsuit or a federal investigation hinges on finding that exact message.
Yeah, the stakes are just a little bit higher there.
Just a little bit. And you aren't just searching your own personal inbox either. You are searching through millions of scattered chats, emails, and files across an entire global corporation.
And, I mean, the scale of that problem is immense. Because for anyone managing data at that level, missing a single document can literally make or break a case.
Which brings us to what we're looking at today.
Right. This is the central problem explored in today's source material, which is this fascinating white paper titled The New Search Paradigm in eDiscovery. It details this massive high-stakes shift that's happening in the legal world right now.
Yeah, we were basically watching the sunset of the traditional Ctrl+F keyword search.
Yeah, exactly. The industry is moving away from that and adopting advanced semantic mathematics and large language models.
So our mission for this deep dive is to really figure out, why this transition is happening in the first place and how this new technology actually works behind the scenes.
Because, I mean, for 3 decades, keyword search was the absolute gold standard in legal discovery.
Yeah, it was the undisputed champion of finding evidence.
It was. But before we can really appreciate the futuristic AI tools taking over, we have to understand why that deeply trusted system is fundamentally breaking down today.
So let's get into the breakdown.
Yeah.
Because to understand it, we have to look at the mechanics of the old system first, right?
Yeah, the old system, which is known as lexical or keyword search.
Which is basically the engine behind almost every search bar you've used for the last 20 years.
Exactly. It relies on Boolean operators, so your basic ANDs, ORs, and NOTs. And it ranks documents using specific algorithms. The most famous one, which you see everywhere in the industry, is called BM25.
Yeah, I've seen that term BM25 pop up a lot in the research. But how does it actually, rank the documents? Because from what I understand, it's not just looking for a word, it's scoring how important that word is.
Right, it boils down to frequency and prominence. So BM25 looks at how many times your exact search term appears in a specific document, but it compares that to how long the document is.
Oh, I see. So the length matters.
It matters a lot. If the word fraud appears 20 times in a one-page email, that document gets a massive score.
Because it's super dense with that word.
Exactly. But the algorithm also balances that against the entire database. So if the word fraud appears in literally every single document in your million-document database, the algorithm assumes the word isn't actually that special and its value drops.
So it's essentially just a giant counting machine. I mean, it doesn't actually know what the word fraud means.
Right, no, not at all.
It just knows the literal letters F-R-A-U-D appear in a certain frequency.
Which is incredibly literal.
Yeah.
And courts have actually loved that literal nature for 30 years because it is highly predictable, it's easily auditable, and most importantly, it's defensible.
Right, because if a judge asks why a document was included or excluded, a lawyer can give a very, very simple answer.
The document contained the word, Your Honor.
Yeah. A word is either in a document or it isn't. It's entirely binary, which feels very safe.
But the white paper points out a major structural weakness in this counting machine approach. The fatal flaw is that keywords find text strings. They do not find ideas.
Right. And because of this, keyword searches are constantly prone to being both overbroad and under-inclusive at the exact same time.
Yeah, which sounds like a paradox, but it happens constantly. Let's look at how that actually plays out in a real case scenario from the sources.
Okay, lay it on me.
So imagine you're investigating a massive corporate data leak.
Like a huge hack or something.
Exactly. So you build a keyword list looking for the exact phrase, data breach. Now, the under-inclusive part of the problem happens when you miss this crucial email from an IT manager who panicked and typed, "We have a huge problem with the Chicago situation," or maybe a message asking to discuss the vendor thing.
Because they didn't use your exact keyword string.
Right. So to the BM25 algorithm, those highly relevant documents are completely invisible.
Wow. So the people involved are talking about the exact event you're investigating, but the computer registers a 0 score.
Exactly. And then the flip side of that is the overbroad problem.
Right, because your search for breach is going to pull in thousands of completely irrelevant emails, too.
Oh, absolutely. You'll get sales teams complaining about a breach of contract or, an employee talking about a security breach at a concert they went to over the weekend.
Which has nothing to do with the IT hack.
Nothing. But the algorithm just dutifully returns every single instance of the string BREACH, completely drowning human reviewers in false hits.
And I mean, just think about your own messages, right? Like on Slack or Microsoft Teams or standard text. We use shorthand all the time.
We use inside jokes emojis.
Exactly. We fragment a single thought across like 5 different short messages. If you were to post tomorrow, a strict list of dictionary keywords would be completely obsolete against the messy, fragmented reality of how you actually communicate.
That's the core issue. The modern data environment, which is this crazy combination of chats, mobile messaging, cloud platforms, all that stuff, it's rendered static keyword lists completely inadequate. Human communication has basically outgrown the counting machine.
You know, it reminds me of playing a deeply frustrating game of Go Fish.
Oh, I love that analogy. How so?
Well, you only get a match if you ask for exactly the right card, right? Like if you suspect your opponent has a dog and you ask, hey, do you have any canines? And they're holding a card that literally says dog, you lose.
Right, they just say, go fish.
Yeah, they say go fish because the literal string of letters doesn't match, even though the underlying concept is exactly what you were looking for.
That go fish dynamic is the perfect way to frame the limitations of the old paradigm, because the technological upgrade we're seeing right now is designed to bypass that literal string matching entirely.
So we are moving into a system called semantic vector search.
Yes, which shifts the entire process from matching letters to mapping mathematics.
Okay, so the white paper states that semantic vector search converts documents and search queries into something called embeddings. I want to break this down carefully because it sounds super technical. What is an embedding in, plain non-academic English?
Okay, so an embedding is a dense numerical array.
Still sounds a little technical.
Fair enough. Simply put, it is a very, very long list of numbers that captures the actual conceptual meaning of a piece of text.
Okay, a long list of numbers that mean something.
Right. To visualize this, imagine a basic two-dimensional graph. On the x-axis, you map how royal a word is. And on the y-axis, you map gender.
Okay, I'm picturing the graph.
Now, if you plot the word king, it sits high up on the royal axis and over on the male side of the gender axis.
Makes sense.
But the word queen sits equally high on the royal axis, but over on the female side.
So they're literally plotted out as coordinates on a map.
Yes, exactly. And because they are both high on that royal axis, they are physically close to each other on the graph. Now take that simple 2D map and expand it to 1,000 dimensions.
Wait, 1,000 dimensions? How do you even visualize that?
Well, you don't. Humans can't visualize it, but a computer handles it easily. These models are trained on enormous volumes of human language, and they learn to plot incredibly complex concepts in this massive, high-dimensional mathematical space.
So the system places text with similar meanings physically close together in that math space.
Exactly. So the search engine is no longer looking for a matching word. It is actually calculating the physical distance between concepts in a 1,000-dimensional space.
Which completely solves the Go Fish problem, doesn't it?
It absolutely does, because now you search for the concept of a data leak, and the system mathematically locates its nearest neighbors.
So it will hand you a document that says unauthorized access, or cyber event, or the Chicago incident.
Yes. Even if those documents do not share a single literal word with your search query, it is searching for the underlying idea.
That is wild. But I mean, finding the related documents is really only half the battle, though, right?
True.
Because once you have this massive cluster of mathematically related emails, you still need to know what they actually say. And that is where large language models, or LLMs, get layered on top of the vector search.
Right. The LLM acts as the reasoning layer. Once the vector search pulls all the conceptually relevant documents out of the database, the LLM can summarize them, it can synthesize timelines, or even answer natural language questions about what a specific custodian was discussing.
But there's a catch there, isn't there?
A huge catch. The major hurdle here is that LLMs have a very well-documented risk of hallucinating.
Oh yeah, where the AI just gets creative and simply invents a plausible-sounding answer.
Exactly. It just makes things up.
We have all seen the headlines about AI hallucinating fake court cases. So how does the legal industry prevent this reasoning layer from just lying to them?
So the architectural fix for this is called RAG, which stands for Retrieval Augmented Generation.
Bag. Okay.
Think of ERG like giving a brilliant but highly imaginative student an open book test with very, very strict rules.
Oh, I like this. How strict are the rules?
Extremely strict. Instead of letting the AI answer a question based on its vast general knowledge of the whole internet, our bag forces the AI to only use specific materials.
The ones we just found in the search.
Exactly. The system first runs that mathematical vector search we talked about to retrieve, say, 10 highly relevant case documents. It packages those 10 documents and hands them to the LLM with a strict instruction.
Like, only use these.
Right. It says, you may only generate your answer using these 10 specific pages. If the answer is not in these pages, say you don't know. It completely grounds the AI's output in the reality of the retrieved evidence.
Yeah, and this combination of vector math and grounded LLMs, it's seeing massive adoption right now.
It really is.
The industry surveys in the sources show that 37% of eDiscovery professionals are actively using AI technology right now. That is a 208% jump in just 2 years.
Yeah, the market has completely blown past the phase of asking whether they should use this technology. The central focus now is entirely on how to trust the results it produces.
See, that brings up a big question for me. Hold on, because I'm trying to picture taking this into a courtroom.
Right.
You have an AI converting abstract human concepts into a 1,000-dimension math equation that normal humans cannot even visualize.
Yeah.
And you are using that to decide what evidence matters in a billion-dollar lawsuit. Doesn't that create a massive black box problem? I mean, you can't just hand a judge a 1,000-dimension math equation and expect them to trust it, really.
You've hit the nail on the head. The interpretability gap you are describing is the single biggest challenge in this space right now.
Because it's just opaque math.
Exactly. A system declaring that two documents are mathematically close is far, far less satisfying to a judge than a lawyer simply pointing out that both documents contain the word fraud.
Yeah, the word is right there in black and white.
Right. And this black box reality is the exact reason why throwing away the old keyword search entirely is actually a terrible idea.
Okay, so the AI isn't a silver bullet.
Not at all. Relying purely on semantic AI exposes this massive kind of ironic blind spot because these advanced semantic models are actually terrible at what keywords do best.
Wait, really? What does it struggle with?
Semantic AI struggles endlessly with known item lookups.
Why would a superpowered AI struggle to find a specific item? That seems backward.
Well, because it relies on mapping conceptual meaning, right? But things like precise Bates numbers, exact transaction codes, unique proper names, or nice acronyms, they carry no conceptual meaning.
Oh, I see.
A random string of numbers, like a transaction ID, doesn't relate to anything in a high-dimensional space. To
Yeah.
the AI, it is just a raw string of characters with zero context.
Okay. The corporate fraud scenario from the sources actually illustrates this perfectly. Let's build out that narrative for a second.
Let's do it.
So investigators are looking for a kickback scheme, right? And they know the illicit payments are tied to a specific transaction code, which is AX994.
Now, if the investigators only use the old lexical keyword search, they will easily find all the automated spreadsheets and the ledger entries containing AX994.
Because the counting machine does its job. It finds the string.
Exactly. But they will miss the sneaky conceptual conversations around the payments where the employees were very careful not to use the actual code.
Like emails asking, hey, did you send the side payment to the shell company?
Right. The lexical search completely misses that human element. But if you only use the new semantic AI search,
Then the AI easily finds all the shady chatter about special arrangements and side payments, but it completely misses the spreadsheets containing the actual AX994 transaction codes because the AI doesn't know what those random numbers mean,
exactly, neither tool can crack the case on its own.
which necessitates the emerging standard in the industry, which is called hybrid search.
Yes, hybrid search is the key.
So you run the lexical keyword search and the semantic vector search in parallel at the same time. Then you use an AI re-ranking step to merge both sets of results into one prioritized list.
That's exactly how it works.
You know, it feels very much like a classic buddy cop detective duo.
Oh, totally. The dynamic is very similar. One side handles the raw facts, the other handles the motives.
Exactly. One detective is this meticulous, completely literal forensic accountant. That's the lexical search. They only care about exact ledger numbers, specific names, and transaction codes.
Right. They find the spreadsheet, but they miss the human element entirely.
And the other detective is a behavioral profiler. That's the semantic search. They're looking for hidden motives, reading between the lines, sensing the conceptual clues.
But the profiler doesn't care about the math, and the accountant doesn't care about the motives.
Exactly. But when you team them up in a hybrid search, you get the precision of the accountant and the conceptual recall of the profiler.
You absolutely need both to get a complete picture of the data. But, even the best buddy cop duo is entirely useless if the police chief won't let them work the case.
And in the legal world, that chief is the judge.
Right. So how do lawyers actually prove this hybrid math is legally sound?
Yeah, the defensibility of this black box in court seems like the final and probably the most critical hurdle.
It is. But courts have navigated massive technological shifts before. The clearest template we have for this transition is how courts handled technology-assisted review, or TAR, about a decade ago.
Right. The landmark case mentioned in the sources is De Silva Moore v. Publicis Group.
Yes. And in De Silva Moore, the court ruled that using predictive machine learning to code documents is perfectly acceptable, provided the process is transparent, it's tested, and it's validated statistically.
So you can't just walk into court and say, well, the AI categorized these documents, Your Honor.
Definitely not. You have to comprehensively show your work.
Because the stakes for getting this wrong today are incredibly high. The white paper notes that concern over AI accuracy jumped to the #2 spot for legal practitioners in a single year, trailing only data security.
And honestly, the anxiety is justified. I mean, courts have already publicly sanctioned lawyers for submitting fabricated, hallucinated AI citations.
Yes, submitting fake case law to a federal judge sounds like a uniquely fast way to end a legal career.
Oh, absolutely. But beyond hallucinations, there is also the massive risk of using open-loop AI systems.
Open loop meaning the data doesn't stay private.
Right. If a lawyer uploads highly privileged client data into a public open-loop AI tool, just to summarize it, that AI might actually train on the privileged data.
Oh, wow. So it could potentially leak those confidential strategies to other users.
Exactly. Which is why judges are now actively writing AI-specific terms into protective orders. They are demanding to know exactly what models are being used and ensuring the data stays in a secure, closed loop.
Okay, so to make this ultimate buddy cop AI system defensible to a judge, the white paper outlines some strict guardrails. The first mitigation step it mentions is statistical validation sampling.
Yeah, and this is very similar to the early days of TAR. You must pull a mathematically valid random sample of the AI's results. Then a human expert manually reviews that sample to calculate the exact error rate.
So you basically have to definitively prove the AI's grade point average to the court.
That's a great way to put it, yes.
And then the second guardrail is maintaining comprehensive audit logs, specifically tracking the exact version of the AI model you used.
Model versioning is so critical because AI models are constantly updated by their developers.
Right.
So if you run a search query on Monday using version 1.0, and then the vendor updates the model to version 1.1 on Tuesday, the underlying math literally changes.
So the exact same search query could yield completely different results.
Exactly. Simply because the spatial mapping of the concepts shifted overnight.
Wow. So tracking the version ensures the process can actually be audited and reproduced later.
Yes. But the final absolute necessity here is the human in the loop. No matter how confident the AI is, a human must make the final call on high-stakes decisions.
Okay, the privilege review scenario from the sources actually breaks down how this human in the loop functions in reality.
Right, because during discovery, lawyers must pull out any documents protected by attorney-client privilege so they aren't handed over to the opposing side.
But privileged emails don't always literally say confidential or attorney advice in the text. Often they just look like a casual business chat where someone is discussing a legal strategy.
And a standard keyword search would miss them entirely. Semantic AI, however, looks at the sentence structure, the formal tone, and the advice-giving language.
It can spot the pattern.
Yes. It spots the pattern of legal advice, like someone saying, based on my review of the situation, we should probably settle even without the literal keyword attorney.
So it flags that conceptual cluster for you.
Exactly. But the key is that the AI does not make the final legal determination to withhold those documents. It just surfaces them.
So a human attorney still has to read the flagged emails, verify the context, and log the official privilege determination themselves.
Yes. The human remains fully accountable for the decision.
Which, it raises a very practical question for me.
Like that.
Well, if human attorneys still have to statistically validate the samples and meticulously log the model versions and manually read all the privilege calls anyway, Does this AI actually save time? Or is it just replacing the busy work of searching with the busy work of auditing?
That is the million-dollar question. The answer is that AI does not replace the lawyer, and it does not eliminate the work entirely. What it does is function as a superpowered triage mechanism.
Like a nurse in an emergency room sorting patients by severity.
Exactly. It drastically compresses the haystack.
Okay, that makes sense.
Instead of a human spending hundreds of hours reading through thousands of totally irrelevant emails just to find the 5 important ones, the AI mathematically surfaces the 50 most likely candidates.
Oh, I see. So the human still has to verify them, but their finite energy is spent actually evaluating the needle rather than digging blindly through all that hay.
Precisely. It elevates the human's role. They get to focus entirely on legal analysis rather than functioning as a manual human search engine.
That is so interesting, and it points to a much larger truth about the trajectory of all knowledge work, whether we're talking about law, business, or research. We are witnessing this fundamental shift from matching literal text strings to mathematically modeling meaning.
We really are.
So for you, the listener, this deep dive reveals that the future of being well-informed is no longer about who has the best list of keywords or who can comb through the most raw data. The future belongs to whoever can best navigate the mathematical relationships between ideas.
It's a huge pivot. The era of relying on the literal letters we type is making way for an era focused entirely on the conceptual context behind them. And, connecting this to the broader foundations of how we resolve disputes, it leaves us with a truly fascinating question as this technology evolves.
What should we be watching for?
Well, if our justice system is increasingly relying on these high-dimensional vector spaces just to decide what evidence even sees the light of day, will future courtroom battles be fought not over the evidence itself, but over the mathematical weight and algorithm assigned to the words we use?